Exam 4 review, question number 11, find the value of the base b. So the graph f of x equals log base b of x contains the points, the given points. So I will do a, so y equals log base b of x. I will plug x and y, so this is x and this is y, so I have 4 equals log base b of 81. To solve this, you're going to turn this into an exponential form. So we say base raised to the answer equals the argument. So it's going to be b to the 4th power equals 81. We're going to make 81 some number raised to the 4th power. So b to the 4th power is equal to 3 to the 4th power. That is what 81 is. Now, by comparison, we have the same exponents. That means the bases are the same. So b is equal to 3. So that is the answer for A. The answer for B, I will do the same thing. So I will plug the values in. -2 equals log base b of 1/4. So we have b to the -2 power equals 1/4. Now I want to write 1/4 with a negative power, so it's going to be b to the -2 equals 4 to the -1. The exponents are not the same, so I'm going to try them to make them the same. B to the -2 equals 2 to the 2 power to the -1. The exponent of the exponent multiplies. So b to the -2 equals 2 to the -2. By comparison, we say b is equal to 2 because the exponents now are the same. So we made them the same so we can compare the bases. C. We have 1/2 equals log base b of 7, which means b raised to 1/2 equals 7. In other words, square root of b equals 7. To solve for b, we're going to square both sides. So b is equal to 49. Last one, we're going to say 3 equals log base b of 1/8. So we have b raised to the 3rd power is equal to 1/8. b to the 3rd power is equal to 1/2 to the 3rd power. Now we can take the power out because there is 1 here, so b cubed is equal to 1/2 all to the 3rd power. By comparison, we see b is equal to 1/2 because we have the same exponents, so the bases are the same. Question number 12. Solve log base 3 of x is equal to -4. We're going to turn it into an exponential form. So 3 to the -4 is equal to x. 3 to the -4 is basically 1/3 to the 4th power equals x. And that will lead to x is equal to 1/81. Solve 8 log of 100 to the -5. So this is going to be 8 log 1/100 to the 5th power. We can do it like that, which now we can split that using the quotient rule into 8 times log 1 minus log 100 to the 5th power, which is 8 times 0, log 1 is 0, minus, and then the 5 comes down with the power rule, so 5 log 100. And that is equal to 8 times 0 minus anything is the same amount, so minus 5 log, we can write 100 as 10 to the 2nd power. Since the base is not written, it's 10. Now we're going to bring that power down. So it's going to be 8 times -5 times 2 log 10 of base 10. Log 10 of base 10 is equal to 1. So this is 8 times -10. -5 times 2 is -10 times 1 is equal to, so this is equal to 1, this log. So it's equal to -80. Log base 4 of 1/16 plus 6. So this is going to be using the quotient rule. This is going to be log base 4 of 1 minus log base 4 of 16 plus 6. 16 can be 4 to the second power, so log 1 is 0 minus log base 4 of 4 to the second power plus 6. I'll bring the power down, so negative 2 log base 4 of 4 plus 6. This amount right here is equal to 1 log base 4 of 4 because the base is equal to the argument. So it's going to be negative 2 times 1 plus 6, which is negative 2 plus 6, which is equal to 4. So that expression is equal to 4. Log base 7 of square root of 7. This is log base 7 of 7 to 1/2. And then we're going to bring the power down. It's going to be 1/2 log base 7 of 7, which is equal to 1/2 times 1, which is 1/2. Find the domain and the vertical asymptote of f of x is equal to ln of x minus 2. To find the domain, you set the argument greater than 0 and solve. So if you add 2, you get x is greater than 2. That is the from 2 to positive infinity. So if you graph it, here is the 2 not included. It's going to look like that. So that is the interval. The vertical asymptote, you set the argument equals to 0 and solve. So if you add 2, you get x is equal to 2, and that is your vertical asymptote.